Hi, Mr. Wright here, and welcome to this film in which I'll run through 18 tough IGCSE questions. Why have I chosen these 18 questions? I've chosen these 18 questions because they are all on topics which are predicted to come up in your paper 2H next week. They're all on my predictions list except for a couple of topics that I've added because I didn't want to leave them out. So I've added a couple of questions on proof. I've added a couple of questions on differentiation, but on a different aspect of differentiation than came up in paper 1H. I've added a couple of probability questions and a couple of Venn diagram questions, just because I had a feeling about those topics and I didn't want to leave them out. Now, please do share this film and the channel with anybody else you know who's taking their IGCSE Maths. It would be really great to spread the word about the channel. And if you're finding the films useful, I would be really grateful if you would just share a link or two. And lastly, please do comment, please do ask a question as you work your way through the questions. You can download the questions, of course, via the link in the description, and then you can have a go at the questions before you watch the film, or you can work alongside me and work through the film that way. Right, that's quite enough from me. But except to say, sorry, that the question numbers are all over the place. So don't worry about the question numbers. The questions are in the same order in this film as they are on the sheet that you're going to download, but all the question numbers are higgly-piggly. But never mind about that. Right, finally, let's get on with the maths. Okay, correct to two significant figures, A, B, and C have these values. Calculate the upper bound for that. Right, so let's first of all start by writing the upper and lower bounds of A, B, and C. So A, those are the bounds for A, the bounds for B, 27.5 and 28.5, the bounds for C, 17.5 and 18.5. Now we'd like this expression to be as large as possible. So we're going to have the largest possible number on the numerator. And we want the smallest possible number on the denominator. Now to get the smallest possible number, I want the difference between B and C to be as small as possible. So I'm going to find the lowest B and the highest C. And so that is what I'm going to put in my calculator to get the answer that the upper bound of that expression is 6.5. Two bags contain discs. Bag A has got 5 red, 6 blue, and 1 white. And bag B has got n red and the rest blue. James takes at random a disc from A, and now Lucy takes one from B. Given that the probability that they both take a red disc is 2/15, find the value of n. Well, let's find an expression for the probability that they both take a red disc. Probability that the first disc is red is 5/12, and the probability that the second disc is red is n out of 25, and you know that that product has to equal 2/15. Right, well, I can cancel here, cancel there. So on the left-hand side, I get n over 60, and that equals 2/15. So multiply both sides by 60, and that will tell me that n is 8. So before I do anything else, bag B has got 8 red and 17 blue out of its 25 discs. Hence, calculate the probability that James and Lucy take discs of different colours. Well, there seem to be lots of different ways they can take discs of different colours. So I'm going to find the probability that they take discs of the same colour, which is going to be the probability that they both take a red plus the probability that they both take a blue. Well, the probability that they both take a red, we already know, is 2/15. And the probability that they both take a blue is the probability that the first of them takes a blue, 6 out of 12, multiplied by the probability that the second of them takes a blue, 17 out of 25. So, a little bit of maths, and I work out But the probability of them both taking the same is 2 15ths plus, that's a half, so it's going to be plus 17 over 50. Stick that into my calculator. 17 over 50. So the probability of them both taking the same disk is 171. Is a 71 150ths. So the probability that they'll take different ones is 1 minus 71 over 150, which is 79 out of 150. So there is the solution to question number 3. Okay, I'm going to take the expression for y given to me here and substitute it into the first of the equations. So that's going to give me x squared plus 10 minus 2x squared equals 20. So now I simply need to solve this quadratic equation. That's going to be 40 minus 40x plus 4x squared equals 20. So on the left-hand side, I've got 5x squared, I've got minus 40x, I've got plus 100, minus 20 from both sides, gives me plus 80 equals 0. Divide everything by 5. So now all I've got to do is to solve this quadratic equation. I can factorize it. It's x minus 4 times x minus 4 equals 0, so there's only one solution. X is 4. Okay, well, if x is 4, I know that y is 10 minus 2x, which is 10 minus 8. So I know that y is 2. So my solution is x is 4, y is 2. 2. N is a positive integer. Explain why 2n plus 1 is an odd number for all values of n. Well, if n is a positive integer, then 2n equals even, as it's a multiple of 2, which means that 2n plus 1 is odd. Okay, now b. Show using algebra that the total of any 4 consecutive odd numbers is always a multiple of 8. So I'm going to need to build an expression up for the total 4 consecutive odd numbers. Well, part A has given me the expression for one odd number, 2n plus 1. The next consecutive odd number is going to be 2 more than that, so 2n plus 3. The next one is going to be 2n plus 5, and the fourth consecutive odd number is 2n plus 7. Now, let's simplify that. I'm going to get 8n plus 16. Okay, now how can I show that that's always a multiple of 8? Well, the answer is show that 8 is a factor of it. So there we go. There I have shown that the sum of any 4 consecutive odd numbers is always a multiple of 8. A and B are 2 sets, right? The universal set has 36 numbers in it. B has 21 elements. A intersection B has 8 elements. And there are 18 elements which are not in A. Complete the Venn diagram to show the number of elements in each region. Right, well, I know there are 36 elements in the universal set, but I'm not sure where to put them. I know there are 21 elements in B, but I'm not sure where to put them, because some might be here and some might be there. Aha, look, there are 8 elements in the intersection. Good, so that's dealt with that piece of information. Not in A, there are 18. Well, not in A could be here, here, or here. No, not that last one, but not A. Could be in those 2 places, so I can't use that yet. Go back to the beginning. Aha, look, the number in B is 21. 8 of them are there, so 13 must be there. Right. Can I use the number not in A is 18 now? Let's have a look. So not in A, it's going to be these 13 and any here. These 13, so there must be 5, which do not lie in A or in B. Right, so I've used that piece of information. Now it tells me that the total number of elements in the universal set is 36. Well, I've got 26 of them here, which means that there must be 10 of them there. Okay, find the number in A or B. Well, that's 10, or the 8, or the 13, which is 31 elements in A union B. Right, find the number of elements which are in A and not in B. So they've got to fulfill both of those criteria. So they're going to have to be in A, so they have to be those ones, but they also have to be not in B. Well, these 8 are in B, aren't they? So I'm just left with 10 elements in answer to that question. And that is question 4 done. Question 3, complete the table of values for y equals x cubed minus 3x squared plus 5. Okay, so if x is 2, then I'm going to have 8 minus 12 plus 5 gives me 1. X is 3, 27, minus 27 plus 5 is 5. X is 4, x cubed, minus 3 16s plus 5 gives me 21. Okay, on the grid, complete the graph. Okay, well, when x is 2, now I have to be quite careful of my scale here. I see it's 2 little squares to a unit on the y-axis. So I've got 2, 1. So 2, 1 is here. Okay, and then I've got 3, 5. And 4, 21. So 2 squares up. There we go. Okay, and I'm going to continue that with a nice smooth curve like this. All right. Okay, good. Right, use the graph to find an estimate for the solution to the equation y cubed minus 3x squared plus 5 equals 0. So I need to find what x values make the function equal to 0. Well, clearly it's going to be the x values that give me a y of 0. So there's only going to be one solution, and it's here. And that looks to me as if it is minus 1.1. So my answer here is minus 1.1. By drawing a suitable straight line on the grid, find an estimate for the solution of this equation. Right, now, the line that I've got on the grid already, the graph I've got on the grid, is this one. So I need to rearrange the equation I'm given so that I've got on the left-hand side the line I've already got and see what expression I get on the right-hand side. Now, in order to change that into what I want, I'm going to need to have subtracted 2x from both sides. And I'm also going to need to have added 1 because a 4 has become a 5. So I need to draw the line y equals minus 2x plus 1 on my graph and see where my two graphs cross. Y equals minus 2x plus 1. Right. Okay, well, I'll do this in green. Plus 1 on the y-axis, and so the y-intercept's 1, and the gradient is minus 2, which means that if I go 3 along, it's going to have to go 6 down. So that's 1 down to here. Okay, so I can join up these 2 points, and that will be the line y equals minus 2x plus 1. And the value of x which solves the equation is this value of x here, which looks to me as if it's minus 0.8. Minus 0.8. Okay, there is the solution to that question. Question 4. V is inversely proportional to the square of t. So that means that V is k over t squared. Express V in terms of t. Oh no, wait a minute. When V is 28, V is 28 when t equals 2.5. So I can substitute those values in. So 28 equals k over 2.5 squared. So that would mean that k will equal 2.5 squared times 28, which gives me 175. So k is 175, which means that I can return to my formula, and instead of k over t squared, v is 175 over t squared. And there is v expressed in terms of t. Work out the value of v when t is 6.25. Well, I know the formula now. V is 175 divided by t squared, so that's going to be 175 divided by 6 1/4 squared. Okay, so 175 divided by 6.25 squared gives me an answer of 4.48. And that is the solution for question 4. Question 2. PQRS, that's the large quadrilateral, and PLMN, that's the small quadrilateral here, are similar quadrilaterals. Okay, PNS, PLRS. LM is parallel to QR. Okay, fine. All right, work out the length of MN. Let's just call that X for a moment. Right, now we know that the large quadrilateral is similar to the smaller quadrilateral. Now the large quadrilateral has a base PS of 20, and the smaller quadrilateral has a base PN of 12. So if I work out that scale factor there, 20 divided by 12, tells me that the scale factor from small to larger is 5/3. Great. Now I'm being asked to work out the length of x, which corresponds to the length of SR. So x is going to be SR divided by 5/3, because I'm going from larger to smaller. So 13.5 divided by 5/3 gives me 8.1. Good, so I can now label this one 8.1. Work out the length of LQ. LQ is this length here, isn't it? Now, here's LQ. If I knew the length of PQ, I'd be laughing because I could just subtract away this 9. And I can work out PQ because it corresponds to this 9, doesn't it? It's going to be 5/3 times 9, which is 15. So PQ is 15, which means that LQ is 15 minus PL, which is 9. It gives me a length of 6 there. Okay, now the area of PLMN, that's the smaller one, is A, and the area of the larger one is KA. Well, I know what K is, because the linear scale factor is 5/3. So the area scale factor is 5/3 squared, or 25/9. So I know that the area, that K is 25/9. Great. The area of the shaded region is equal to whatever it is, 105.6. Find out the value of A. Okay, well, the area of the shaded region is the difference between the larger area and the smaller area. The larger area is KA, so the larger area is 25/9 times A minus the smaller area, which is A. That's the difference between the larger and the smaller, and I know that equals 105.6. So there's an equation. Multiply everything by 9. Well, actually, I'll just do 25/9 of A minus 9/9 of A. So I get 16/9 of A is 105.6, which tells me that A is 105.6 multiplied by 9 divided by 16, which gives me an answer of 39.6 square centimeters for the area of this smaller quadrilateral. And there's my solution to that question. Question 5. The diagram shows the elements in sets A, B, and the universal set. Write down the elements in not A. It's going to be all of them except those elements which are in A. So the elements which are not in A are 5 and 6, 7 and 4. Right, find the complement of A intersection B. Well, A intersection B is the 8 and 9. So those that are not in A intersection B are all the others, 2, 3, 10, 5, 6, 7, 1, and 4. It asks me to find the number of elements in the complement to the intersection. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements which are not in A intersection B. Right, find the elements in A intersection B or something else. Well, the ones in A intersection B, is 8 and 9. So those two are going to qualify. They've got to be 8 or 9 or not in A or B, not in the union. Well, the ones which are not in the union are 7, 1, and 4. So to qualify, you have to be in either the first category or the second category. So there are 5 elements which qualify, and they are those ones. Okay, now let's have a look at this next one. Right, A intersection C is an empty set, so A and C have got nothing in common. All right, so C does not include any of the elements in A. B union C, they're in B union C, so either in B or C. Well, B or C is going to be those in B, 8, 9, 5, 6, 8, 9, 5, 6, it was 7. So 7 must be in C, mustn't it? So 7 is definitely in C, but I've got to have 3 of them in C, but none of them are in common with A. So it's going to be 7, 5, and 6. So the elements in C are 7, 5, and 6. And there is my solution to question 5. Question 2. P is directly proportional to Q cubed. So I can write down that equation there. P is 270 when Q equals 7.5. So substituting in P and Q gives me that. So that would imply that K is 270 divided by 7.5 cubed, which is 7.5 cubed, which gives me a K of 16/25. So my formula is that P is 16/25 times Q cubed. Find a formula for P in terms of Q. I've done that. Work out the positive value of Q when P equals Q. Right, well here's my formula for P. P is 16/25 Q cubed, and P has to equal Q. So Q will equal 16/25 of Q cubed. If I divide all the way through by Q, I get 1 equals 16/25 Q squared. Multiply or divide both sides by 16/25 gives me Q squared equals 25 over 16. So Q would equal root 25 over 16. Now I'm asked for the positive value, so that will just be 5/4. Okay, so that is that. It has 9 counters. Each counter has a number on it. Here they are, all the numbers from 1 to 9. Like, she puts the 9 counters into a bag, takes at random one from the bag, does not replace it, takes at random a second counter. Work out the probability that the number on each counter is an even number. Well, let's have a look. Of her 9 counters, she's got 1, 2, 3, 4, 5 are odd, and 4 are even. Right, the probability that both of her numbers are even. Well, the probability of the first one being even is 4 out of 9. And having chosen that one and not replace it, the probability of the second one being even would be 3 out of 8. So the probability of them both being even is a sixth. Okay. Work out the probability that the number on the first counter added to the number on the second counter gives an odd. Well, what could happen here? She could get an odd on the first and an odd on the second. If she did that, then her total would be even. So we're not interested in that outcome. She could get an odd on the first and an even on the second. If she did that, then her total would be odd. So we are interested in that. She could get an even and then an odd, which would give us a total of an odd number. So we're interested in that. She could get an even and an even, which would give us an even total. So we're not interested in that. So we're interested in the middle two here. Right, let's look at this first one. Probability of an odd followed by an even. Well, to start with, there are 5 odds out of the 9. If she takes one of those and doesn't replace it, what's the probability of the next one being even? Well, 4 out of 8. So the probability of that outcome is 20 out of 72. Right, let's have a look at the second possibility here. The chance of the first one being even is 5 out of 9. She doesn't replace it, so there are 8 left. Okay, and 5 of those 8 would be odd. So 4 out of 9 times 5 out of 9 is another 20 out of 72. So altogether, the probability of one or other of those events happening is 40 out of 72. I divide top and bottom by 8, then I get the answer 5/9. Right, there is Gemma sorted. Right, P, Q, and R are points on a circle with a centre of O. So here's the centre of the circle. Oh, look at that. The radius of the circle is 5. I can see that quite clearly. QS is the diameter of a circle. Yes, okay. Diameter of QS and PR intersect at the point T. This looks like intersecting chords theorem to me. OS is 5 as marked. That's also the radius. QT is 3, TR is 6. Okay, work out the length of PT. Right, so intersecting chords theorem tells you that PT times 6, TR, equals 3 times ST. Now, do I know ST? No, I don't, but I know that's 5. This bit's 3, so OT must be 2. So now I know ST is 7. So 6 times PT equals 21. So PT equals 21 over 6, 3.5 centimetres. There we go, question 4. Question 5. Here are 7 cards. 1, 2, 3, 4, 5, 6, 7. Yes, there are. Harry takes at random 2 cards. Calculate the probability that the numbers on the 2 cards are the same. Right, well, that could mean then he can't get a 1 and a 1, but he could get a 2 followed by a 2, or a 3 followed by a 3. A 4 followed by a 4 is not a possibility. Right, the probability of getting a 2 followed by a 2 is 2 out of 7 multiplied by 1 out of 6. 2 over 42. And the probability of getting a 3, the first one, followed by a 3 on the second occasion, is 6 out of 42. So altogether, I get 8 out of 42, which is 4/21. Okay. Calculate the probability that the sum of the numbers on the 2 cards is 5. Right, we just need to think how that could happen. And would it work? Could he get a 1 first? He could. He could get a 1 followed by a 4, couldn't he? So he could also then get a 4 followed by a 1. He could get a 2. That would have to be followed by a 3, or a 3, which would have to be followed by a 2. So I think those are the 4 outcomes which qualify. So the probability of getting a 1 on the first card is 1 out of 7, because there's only 1 1. Probability of getting a 4 is 1 out of 7. So that probability, 1 out of 6, of course, because there are only 6 cards left. So that probability is 1 out of 42. Right, the probability of getting a 4 with this first is 1 out of 7, and then a 1 is 1 out of 6. So again, 1 out of 42. The probability of getting a 2 is 2 out of 7, followed by a 3. 1, 2, 3 threes out of those 6. So that's going to give 6/42. So the probability of getting a 3 is going to be 3 out of 7, followed by the probability of getting a 2, which is 2 add a 7, which is another 6 over 42. So altogether I've got 12, 13, 14 out of 42, which is 1/3, is it not? So the probability of the sum of the numbers on the two cards is 5, is 1/3. Right, we've got two chords of a circle, so this is likely to be the intersecting chords theorem. I've got to work out the value of x, which is here. Okay, so using the intersecting chords theorem, 8 times x equals 6 times 6.5. So 8 times x is 6 times 6.5 is 39. So x is 39 divided by 8, 4.875 centimeters. The size of each interior angle of a regular polygon with n sides is 140. Work out the size of each interior angle of a regular polygon with 2n sides. Okay, let's concentrate on the first regular polygon here. It's got an interior angle of 140. So its exterior angle is 40. So its number of sides is 360 divided by 40. It's a 9-sided polygon. Great. Right, now let's have a think about the second regular polygon in the question. It's got 2n sides, so its number of sides is going to be 18. We're asked to find its interior angle. Well, that's going to be 180 minus the exterior angle, which is going to be 360 divided by 18. So that's 180 minus 20. So this polygon's interior angle is 160 degrees. Okay, that is number 4. Question 1. I need to write this expression as a single fraction. I see I've got a subtraction and a division. So I'm going to do the division first. So I've got 5 minus, right, put this in a brick bracket, got x plus 2 over 1 multiplied by x minus 3 over x squared minus 4. Well, that's the difference of two squares, x plus 2, x minus 2. Okay, so I've got 5 subtract. Right, what's going to happen in these brackets here? Well, I can cancel divide top and bottom by x plus 2. So that leaves me with x minus 3 over x minus 2. Okay, right, so I've got 5 over 1. I'm going to write them both over x minus 2. So I'm going to have 5 lots of x minus 2 over x minus 2 minus x minus 3 over x minus 2. Best put that in brackets and just be quite careful because I've got a minus outside the bracket there. So that's going to give me 5 lots of x minus 2 minus x minus 3 all over x minus 2. Multiply out that bracket, 5x minus 10 minus x plus 3 over x minus 2 will give me 4x minus 7 over x minus 2. I can't factorize the top, I can't factorize the bottom, so that must be my final answer. 4x minus 7 over x minus 2. Question 3. Factorize this expression. Well, that is the difference of two squares. 2x plus 1, lots of 2x minus 1. I assume that that's the answer for section A is going to help me in section B. Let's have a look. Solve that equation. Okay, well, let's start off by rewriting it using what we've just worked out in section A. Factorize the denominator there of that fraction. Okay, right. Well, you can do this in several ways. I'm going to add the two fractions on the left-hand side. So I'm going to have 4 lots of 2x minus 1 over 2x plus 1, 2x minus 1 plus 1 over 2x plus 1, 2x minus 1 equals 3. So that gives me the top, which is 8x minus 4 plus 1, all over 2x plus 1, 2x minus 1 equals 3. I'm going to multiply. No, I'm not. I'm going to simplify the denominator here. 8x plus 3 over 2x plus 1, 2x minus 1. I was kind of thinking that perhaps I could factorize the top and do some cancelling, but I don't think I can. So now I'm going to resort to multiplying top and bottom by the denominator of that fraction. So I'm going to have 8x minus 3 equals 3 lots of 2x minus 1, sorry, 2x plus 1, lots of 2x minus 1. Which is going to give me 8x minus 3 equals 3 lots of 4x squared minus 1, which is going to give me 8x minus 3 equals 12x squared minus 3. I'm going to take my 8x minus 3 onto the other side here, because I've got a quadratic equation, so I'm going to set it equal to 0. If I plus 3 to both sides, then the constant term disappears. Now I'm going to look to factorize the left-hand side. So that's 4x can come out there, leaving me with 3x minus 2 equals 0. So my two solutions are either drawn out at x equals 0 or x equals 2/3. So there we go. There's my solution to question 3. Question 5. Solve this quadratic equation, showing you're working clearly, giving your solutions correct to 3 significant figures. Right, so clearly I'm going to need to use the formula here. A will be 1, B will be minus 4, C will be minus 1. So x equals minus b plus or minus the square root of b squared, which is minus 4 squared minus 4 times 1 times minus 1, all over 2 times 1 is 2. Right, so that gives me 4 plus or minus the square root of 16 plus 4 is 20. Okay, so now I'm going to use my calculator to give me my two solutions. 4 plus the square root of 20 equals, divided by 2 equals 4.23. What am I doing? 3 significant figures, so 4.24, or 4 minus root 20 equals, divided by 2 equals 0, minus 0.3 significant figures here, 236. There we go, right. Hence or otherwise, so probably hence, solve this equation. Well, if I look at the equation that they're asking me to solve, this one here, it looks identical to the one in section A, except that question A's x is equal to x plus 3 here. So presumably my solutions would be x plus 3 would be 4.24, or x plus 3 would be minus 0.236. So in this case, x would be minus 3 from both sides, 1.24, and minus 3 from both sides here as well, minus 3.236. So there are my solutions to question 5. Just a moment. Give this one to 3 significant figures, minus 3.24. There we go. Okay. Well done for making it through that film and for working through those questions. I really hope it's helped. Please leave me a comment in the comments telling me how you found the film, asking me any questions, and please do share the channel with anybody else you know who might find it useful. Okay, see you in the next film.